Hello friends, in this video I am going to explain to you how the MQTT protocol works. Now to explain about MQTT, MQTT is a very simple communication protocol which needs very fewer bytes of control packets. As mentioned here, MQTT uses a set of control packets which are the connect packet, which is the first packet which the publisher or the subscriber sends to the broker. And for each connect packet, the broker responds with a connect acknowledgement packet. Now the connect acknowledgement packet is sent as a response to connect packet, and the connect acknowledgement packet might also have some accompanying bytes which will indicate whether the connection was accepted or rejected. Suppose if you send a wrong username or password in the connect packet, then the broker might just reject the packet and still send the connection acknowledgement packet. Now suppose if you want to send a message to the broker, then what you do is you send the publish packet along with the topic name you want to publish to and the message. When you send the publish packet, the server responds back with the publish acknowledgement packet. Now the other important packet which we are going to study in this tutorial is the subscribe packet. So subscribe packet is sent by the client to the broker indicating that it wants to subscribe to this particular topic, and if any message comes to this topic, then the broker should send that message to the subscriber. Now when you send that, the server sends an subscribe acknowledgement packet with the control packet number 9. Now if you want to keep the connection alive between the server and the client, then you need to keep sending the ping request, and the server will respond with ping response, indicating that the connection is still alive. To successfully test the MQTT protocol, we need three entities: the broker, the publisher, and the subscriber. Subscriber is the listener and publisher is the sender. Broker, what it does is it takes in the message which is sent from the publisher and delivers it to all the subscribers who are listening to that particular topic to which the publisher has sent the message to. Suppose if there are two subscribers listening to topics coffee, and the publisher sends a message to the broker with the topic name coffee, then the broker takes care of sending that message coffee to both the subscribers which were listening to that topic name called coffee. The publisher only needs to send that particular message with the topic name to the broker, and broker takes care of forwarding the messages to all the subscribers whoever are listening to that particular topic. Now for the first scenario, let us consider we want to publish a message to the broker, and there are some other subscribers waiting for that message listening to a particular topic. Now what we need to do is we need to send the connect packet to the server. So if your server does not need any authentication, then we just send a plain simple connect packet. I will also tell you how to send a connect packet with username and password in the later part of this tutorial. Now when you send the connect packet, there are some things which also need to be sent in that packet. In the start of the connect packet, we send the first byte, which is the MQTT control packet type. So this byte will indicate whether it's a connect packet or a subscribe packet or a publish packet. So for connect packet it is 10, and the next byte shows the remaining bytes which are following in the packet. This field indicates to the broker that there are still these many bytes remaining in the packet, and you need to take them and interpret them correctly. This is called the remaining length packet. Now after this, the next bytes that need to be sent is the protocol name. Now since we are using the MQTT protocol, we send the length of the protocol name, which is MQTT, which is 4 bytes, and we send that number of bytes information in these 2 bytes. So first we send the length of the field, which is MQTT 4 bytes, and then we send the protocol name. Now after this, we send the protocol level. I didn't find much information regarding the protocol level 4, so we will just keep it what they have given it as default. If you find more about this protocol level, then just let me know. And then the next byte is byte 8, which is the connect flag bits. In these flag bits, we indicate whether the username is present in the packet or if the password is present in the packet, and there are different control settings like the clean session or a will flag or QoS or quality of service. Now for our demonstration, we are not using the username and password flag, so we will only set the clean session to 1. Clean session only indicates to the server that you need to start a clean session whenever this field is set. So this field will be something 02 for us because we are only setting clean session. And then is the keep alive field. So the keep alive field, what it does is it tells the server that even if I don't send any data to you, just keep the connection alive for these many seconds. So this MSB and LSB indicate the seconds which the server needs to keep the connection alive for. By default, we are setting it for 60 seconds, telling to the server that you need to keep this connection alive for at least 60 seconds, even if I don't send anything. So this is the full length of the connect packet. So after we send the control packet type, then we send the protocol name along with the length, and then we send the protocol level, which is 04 by default, and then we send this byte which indicates different connect flags, and then we send the keep alive values. Now after these bytes, we also need to send a client identifier, because the broker needs to keep track of who is sending this packet. So we identify ourselves with a client identifier. The client ID can be a combination of alphabets and numbers. So you can select your own client ID. So in my example, I have set it for ABCDEF. Now suppose if your broker needs authentication, then you need to send the username and password also in the connect packet. So first what you do is you set these two flags, username and password flag, telling to the broker that there is a username and password in this packet, and then it will take and authenticate it. And if there are any username and password, just send them after those bytes. So the format is simple. First you send a 2-byte value, which is the username length, and send the username, and you send the password length, and you send the password. So that is the connect packet. I have created a simple MQTT packet here to explain it to you. As I explained earlier, this is the control packet type, which is 10, which will indicate to the broker that it's a connect packet. And then this is the remaining length, which is 12 in hexadecimal, because the length of this packet is 18 bytes, which is hexadecimal 12. And then what follows is the protocol length, which is 04. And what follows is the protocol name MQTT in hexadecimal. And this is the protocol level 04 as given as a default value. And this is the connect flags. 02 means we are not setting the username and password field, we are just setting the clean session field. And then is the keep alive interval. So 3C is nothing but 60 seconds. See here, so we need to give that in hexadecimal. And then what follows is the client ID length. So our client ID is of 6 bytes, ABCDEF in hexadecimal again, and the client ID length is 6 bytes. Now let us look at the publish packet. Also, when you send a connect packet, the broker responds back with a connect acknowledgement packet, which will have this value 2002. This will be 2 bytes, and next what follows will be connect acknowledgement flags, which will indicate whether the connection was authorized or not. And the next 2 bytes will be the connect acknowledgement flags and a return code. The return code will indicate whether the connection was authorized or not. Suppose if you receive 05, then the connection was refused and it was not authorized. So you need to receive 00, which will indicate that the connection was accepted. Now let us look at the publish message MQTT packet. First byte in the header will be the MQTT control packet type 3, which will indicate that it is a publish packet. And then the second part of the byte will have some flags. You can read about it. We will just keep it as 0, as shown here. And then the next byte is the remaining length, which is 13. 13 in hexadecimal is equal to total 19 bytes. So the total length of this packet is 19 bytes. And then we send the topic, which is of 8 byte lengths. And then we send the topic and the message. So first we indicate the topic length here as 0008, and then we send the topic. After that, whatever follows after 8 bytes is considered as a message. So the publish packet is very simple. After this, you should get a publish acknowledgement packet from the broker, which will be 2002. And the last packet is the subscribe packet. Now the connect packet part of the communication mechanism remains the same for the publish and the subscribe. So even the publisher or the subscriber have to send the connect packet first, and then once he is authorized, then only he can publish a message or start listening to the topic. Now in the subscribe packet, the first byte which is sent is 82. So that's what we have done here. It will identify to the broker that this is a subscribe packet, and then as usual we are sending the remaining length bytes, which is 0D. 0D meaning that it is 13 bytes in length. And then we also send a packet identifier field, so it is 2 bytes. It's a user set number, you can set it to any value you want, it is for your reference. So I just set it for 0001. And next we send the topic, which is Valetron, and this is the topic we want to listen to. And in the publish packet message also, we are publishing the message to the Valetron topic. And first what we do is we send the topic length. Valetron is of 8 bytes, so we send 0008. And then we send the quality of service, which is 00. So that's the quality of service we're expecting from the server. And then the server will send an subscribe acknowledgement packet, which is 90. So this is the procedure we use to send a connect packet, publish packet, or a subscribe packet without any authentication. Now suppose if you have an authentication required on the server, then what you do is you need to send the username and password field at the end of the packet. So everything will remain the same. Only thing is we will send the username and password field. First we send the length of the username field, and then we send the length of the password field, and then we send the password at the end. Now this example what I am going to show is for the cloud MQTT server. This server requires that you send the protocol name as MQISDP instead of MQTT. And also the protocol level needs to be 03. So what happens here is, first the connect packet, the name will remain the same 1010, and the remaining length will change because we added the username and password fields. And next is the protocol length, which is MQISDP, which is of 6 bytes. So we send the packet length as protocol length as 0006. And next what we send is the protocol level, which is 03, which is what the cloud MQTT server expects. Now in the connect flag fields here, as you can observe, I have written C2 instead of 02. Here what I am doing is I am setting the username field and the password field in this flag list. So it will be 110010. So it will be C2. And next this is the keep alive intervals, which is 003C, which will be 60 seconds. And this is the client ID length, which is ABCDEF is the client ID. And next is the username length 8 bytes, and this is the password length. Now this username and password fields are obtained from the cloud MQTT control panel. So here when you create an account, they give you a free version of the server, which you can take a trial. So this is the username, this is the password, and the port you want to connect is 17434. So it will be different for your account whenever you create it. Just test it out. And they also have this WebSocket UI, which you can use to send and receive messages. So this WebSocket UI will also subscribe to whatever topic that is incoming to your Cloud MQTT console, and it will also have it is also having a option to send any packets to a particular topic. So we will see it in a few moments. First, let me show you some of the basic subscribe and publish commands. Now what I have done is I installed the Mosquitto MQTT broker on my laptop, using which we can easily test the MQTT protocol on my laptop on the localhost. So first let us subscribe to a topic. We can do that by using the command mosquito underscore subscribe. Give the host name, which is localhost, and give the port name, and then you give the topic, which is Valetron, and you hit enter. So now it is listening to the topic Valetron. This is our subscriber now. Now let us go to our publisher and send and publish a message. Mosquitto underscore pub -h host name, and then the port name. 1883 is the default MQTT port, and next we need to give the topic and then the message. Okay, now when I hit enter, the message is published to the broker, Mosquitto broker, and the subscriber, whoever is listening to the topic Valetron, should receive the message hello Ravi. Now as you can see, the message has arrived on the subscriber. Now I will create one more subscriber which will listen to a different topic. Okay, now it is listening to the topic Valetron 1. Now I will publish a message to Valetron topic hello Ravi. Now as you can see, only the subscriber who is subscribed to Valetron topic is getting the message, and if I publish a message to Valetron 1, now the second subscriber will receive the message. So this is the basic example. Now this is done for the localhost. Now what I will do is, instead of subscribing to the local broker, I will subscribe to the cloud MQTT broker here. For this we will need this port number, username and password. Now I will subscribe to the topic Valetron, but the port number is changed 17434, and then the host name is m10.cloudmqtt.com, and then we also need to provide the username and password. So we give it the username -u dxxkgkpp, and the password will be, we give it as capital P, because -p will mean that it is a port number. QAUZ BDASIULX. Let's see. Okay, looks like it has subscribed to the topic Valetron. Now let us try to publish a message. Port number is 434, and host name we need to change m10.cloudmqtt.com, and then we need to give the username and password as well. -u, username is dxxkgkpp, and password is QAUZBASILX. So now let us see. Oops, not authorized. Maybe I typed the password wrong. Sorry, I missed D here. So hopefully that's the only error. Now I will I will send the message to Valetron topic. Okay, so the cloud MQTT broker has done its work, and we were successfully able to publish a message using authentication to a subscriber who was listening to the cloud MQTT broker. Okay, Now let us test this WebSocket UI present on the server. Now what it does is whatever message we publish here, they automatically arrive on the WebSocket UI. Okay, as you can see, the message automatically is displayed on the Cloud MQTT console. Okay, so the Cloud MQTT subscribe and publish are working correctly. Now, the way we have understood the packets, what we will do is we will try to send raw packets over TCP to the Cloud MQTT server, or we can test it first on the localhost also. So for that, what I will do is I will subscribe to Electron topic on the localhost, and I will use this software Hercules. So using this software, I will send TCP packets uh, which will have the MQTT packets in it, and try to communicate with this MQTT broker which is installed on the localhost. So I chose this Hercules software because it is having an option to send packets in hexadecimal, because that's what we will need here. Now let us now for this we should first send the packet, connect packet. Now for the testing on localhost, we should send the connect packet first, which is 10, 12, this. So we need to send them in sequence without any spaces. So I have just copied that here and removed the spaces. So we will put it here, and then we will get the publish packet 30137669. And I think I already pasted the subscribe packet. So this is a subscribe packet 8200. Paste it here. Now we will open our server and try to see if any message published here will arrive. Now we will see if any message I published to the local host here. Now I have given the IP address of the local host and the correct port number. Now first we will hit the connect button, which will connect or create a TCP connection with the MQTT broker running on my laptop. So it's connected now. Now I will first send the connect packet. So the connect packet is sent, and there is also an acknowledgement, but this software doesn't show it. And next what we send is we send the publish packet. So when we publish, when we send the publish packet, the whatever the message is present, it should arrive on our subscriber. So as you can see, hello Ravi has arrived here. So that's what was sent to the Electron topic. Now on the other side, suppose if you want to subscribe to the topic, we will hit send. We will send the subscribe packet. So now it is subscribed to the Electron topic, and there is an acknowledgement, but as I said, you cannot see it. Now I will send a publish message here to see if a message arrives to the local host. So this is the command. I will change the topic name. It's Electron and the message is hello Ravi. Now as you can see, the message has arrived, which is hello Ravi, and the topic name is Electron. The black letters are the letters which are coming from the broker to the subscriber, which is the Hercules software. So we can change the message. We will receive it directly. This should be coming here also. Yeah. Now since we have already published the message and got it back, and now we have subscribed to the same topic to which we are publishing here. Now if I send the publish packet to the topic Valetron, then it will reach to other subscribers also, along with it will be sent to this software also, because it has also subscribed to the, oops, it's closed the connection because we left it idle for 60 seconds. Now we will initiate the connection again. We will send the connect packet, and then we will hit the subscribe packet, and then now we are subscribed to the topic Valetron. Now if I send the publish packet, it will go to other subscribers and come to us also. As you can see, this is the publish packet and this is the packet received as a subscriber. So it will appear in double. So this is the value that is being sent, and the same value has been received back. Okay, this is the demonstration on the localhost. Now using authentication packet which we created, and now let us try to, you know, send a message to the cloud MQTT server. For that we will create a subscriber. The subscriber is already there, it's alive. Now we will just try to send the connect packet, which is this one, 1023 102c 4c48. It's a long packet which I have kept in the notepad here. So we paste it here, and now we change the host, and the port number is 17434. Now we will hit the connect button. Sorry. Now let's hit the connect button. Now we are connected to m10.cloudmqtt.com. Now we will first send the connect packet with authentication. Okay, and now we will hit the publish packet. Okay, so the message has arrived on CloudMQTT. Now we will send the subscribe packet. Now it is subscribed to the CloudMQTT broker to the topic Valetron. Now I will send a packet from here to Valetron topic. It should arrive here. As you can see here. Now I will send a message again. It's arriving here. Now I will subscribe to the CloudMQTT broker to the topic Valetron, and I will send a message here. It has arrived here. Now I will send message here, and it will arrive on both places. Hello Ravi. Hello Ravi. So this is how we send and receive messages on MQTT protocol. So Cloud MQTT is one of the examples I used because it supported authentication and it was easier to explain. You can apply these same things to different servers or free cloud softwares which support MQTT. And if you want this Excel sheet for study, I will put it on my blog www.raviYP.com. And if you have any questions or doubts, you can write to me at ravi@valetron.com. And if you like this video, hit the like button, subscribe to my channel, and share with your friends so that they can also be benefited. So that's all, I guess. Thank you for watching.